Z-scores and percentile. Consider an internet site that offers movie downloads. Based on data kept by the site, an estimate of the mean time to download a certain movie is 12 minutes. With a standard deviation of 4 minutes, when you download this movie, the download takes 20 minutes, which you think is unusually long time for the download. On the other hand, when your friend downloads the movie, the download takes only 6 minutes, and your friend is pleasantly surprised at how quickly she receives the movie. In each case, a data value far from the mean is unexpected. The graph below shows the download time for this movie using two different measures. The number of minutes a download time is from the mean, and the number of standard deviation, the download time is from the mean. The number of standard deviation between a data value and the mean is known as the data value z-score or standard score. The z-score for a given data value x is the number of standard deviation that x is above or below the mean of the data. The following formula shows how to calculate the z-score for a data value x in a population and in a sample. In a population, z-score x is equal to x minus mu over standard deviation sigma, while in sample population, z-score x is equal to x minus x bar over the standard deviation. Let us consider this example. Raul has taken 2 tests in his chemistry class. He scored 72 on the first test, for which the mean of all scores was 65 and the standard deviation was 8. He received 60 on a second test, for which the mean of all scores was 45 and the standard deviation was 12. In comparison to the other students, did Raul do better in the first test or in the second test? To find the solution, we compute for the z-score for each test. Z72 is equal to 72 minus 65 over the standard deviation 8 is equal to 0.875. Z60 is equal to 60 minus the mean 45 over 12 due to the standard deviation, which is equal to 1.25. Raul scores 0.875 standard deviation above the mean on the first test and 1.25 standard deviation above the mean on the second test. The z-scores indicate that in comparison to his classmate, Raul scored better on the second test than he did on the first test. The z-score equation, zx is equal to x minus x bar over s, involves 4 variables. If the values of any 3 or 4 of the 4 variables are known, you can solve for the unknown variables. This procedure is illustrated by this next example. Consider, a consumer group tested a sample of 100 light bulbs. It found that the mean life expectancy of a bulb is 842 hours, with a standard deviation of 90. One particular light bulb from the Durabright company, or rather from the company, had a z-score of 1.2. What was the lifespan of this light bulb? The solution: substitute the given values into the z-score equation after you have manipulated the equation to find what is missing. So zx is equal to x minus x bar over s, multiply s both sides, then add the x bar to get the working equation, x equal to zx times s plus x bar. Then substitute the values, x equal to 1.2 times 90 plus 842, x is equal to 950 hours. Most standard examination provide scores in terms of percentile, which are defined as follows. A value x is called p percentile of a data set divided p% of the data values are less than x. For example, in a recent year, the median annual salary for a physical therapist was 74,480. If the 90th percentile for the annual salary of the physical therapist was 105,900, find the percent of physical therapists whose annual salary was A, more than 74,480, B, less than 100,900, and C, between 74,480 and 105,900. By definition, the median is the 50th percentile. Therefore, 50% of the physical therapists earned more than 74,480 per year. Because 105,900 is the 90th percentile, 90% of all physical therapists made less than 105,900. And from parts A and B, we could deduce that 90% minus 50% is equal to 40% of the physical therapists earned between 74,480 and 105,900. The following formula can be used to find percentile that corresponds to a particular data value in a set of data. Given a set of data and a data value x, percentile of score x is equal to number of data values less than x over total number of data values times 100. Consider, on a reading examination given to 900 students, Elaine's score of 602 was higher than the score of 576 of the students who took the examination. What is the percentile for Elaine's score? Solution: percentile is equal to number of data values less than 602 over total number of data values times 100. So it's 576 over 900 times 100 is equal to 64. Elaine's score of 602 places her at the 64th percentile.